Welcome to my C Beginner tutorial focusing on embedded development. This issue covers the unsigned integer data types. The C integer data types you see here are intended to allow code to be portable among machines with different inherent data sizes. All four data types have a different byte size. I think you know that 1 byte has 8 bits. The first unsigned data type has 8 bits, so it consumes 1 byte. The second unsigned data type has 16 bits, so it consumes 2 bytes. The third unsigned data type has 32 bits, so it consumes 4 bytes. The fourth unsigned data type has 64 bits, so it consumes 8 bytes. When you use these unsigned data types, you can be sure that your code will only require the specified memory size on every chip. This first block is used to declare variables and initialize them with a value. You should always initialize variables when declaring them. In the second block, you can see the assignment of the maximum possible values to the variables. If you added 1 after assigning the maximum value to the respective variable, the variable would then be 0. The last block is only there to suppress compile warnings. Otherwise, the compiler will complain that nothing is being done with the variables. It would be possible to suppress this, but you should not do so. Since this program doesn't really make sense, I have to do this here. As you can see, we are already in debug mode at the beginning of the program. Let's examine this program with the debugger. When I skip over the initialization, keep an eye on the variables here. Now all variables have been initialized with 0. Here you can see the assigned value. If you click on the currently selected area, you will see a detailed view of the variables with different codings. The decimal and hexadecimal encodings are the most interesting. Based on the hexadecimal encoding, it is easy to see that this is the maximum for 1 byte. If 1 is added to this variable, it becomes 0. The maximum value range for a 1 byte number is decimal from 0 to 255. Now the maximum possible value has been assigned to the unsigned 16 variable. As before, you can view the variable in memory as well as the different encodings. The maximum value range for a 2-byte number is decimal from 0 to 65,535. Now the maximum possible value has been assigned to the unsigned 32 variable. As before, you can view the variable in memory as well as the different encodings. The maximum value range for a 4-byte number is from 0 up to the value shown here. Finally, the maximum possible value is assigned to the unsigned 64 variable. The maximum value range for a 8-byte number is from 0 up to the value shown here. I have deliberately marked the default value here. What Eclipse displays here for decimal is incorrect and is due to a bug related to GDB. Below the video in the description you will find a link to the script shown here. There you will also find installation instructions for Eclipse, the development environment used here. If you liked the video, please support me by giving it a thumbs up. Thank you for watching. Have a nice day.